Don't walk into your boss's office with a prototype. What you need is a platform strategy and a deployment strategy. And be prepared to answer 3 key questions that your boss is going to ask you. Hi, I'm Sujata.
I'm Altaf. And I'm Ian.
And we're going to talk about these 3 key questions your boss will ask you when you bring in a new prototype. Ian, how about you kick us off?
Well, there's lots and lots of these consumer grade boards more than ever. And it's amazing because it's got so many people writing code and developing. But the challenge is, what are you going to really do for supply chain? How are you going to get volume product of this? What's your reliable long-term source? And then picking parts that can scale back up and down.
Makes a lot of sense. Another thing that occurs to me is that building on these types of hobby platforms could be you're building something with too many features, like it's overkill for your purpose.
Well, it can be. The other interesting thing is, you certainly with our processors, you can pick whatever features are needed and scale up and down in a particular family. But the other aspect of that is some of these platforms don't include the interfaces you need. You might need CAN bus interface or an Ethernet interface. And we have all you can pick exactly which part you need that has those parts built into the microcontroller itself or the microprocessor. Taken, for example, one of our Linux processors, an 8M Plus. Here we provide an complete reference design, so you can build and copy this, or you can go to one of our partners and use one of their SOMs or boards. But the chip itself has so much built into it, and the types of interfaces you really need. So CAN bus, Ethernet, neural net accelerators, camera processors, all in a single chip.
So Altaf, Ian brought up some great points. How would you look at positioning your cost and long-term cost for your platform approach? What are other things you would consider?
Right. So I think since these robots are really going to go into an industrial environment, you have to also select products that are qualified to operate in those industrial environments as well. The operating temperature range. Also, you need to comprehend safety requirements, security requirements. Those aren't necessarily going to be available in these consumer grade products as well. And also, as Ian mentioned, we have a scalable range of different MCUs, all the way from MCX to our RT devices. We have a range of different performance and price points for our i.MX family as well, and a whole range of automotive processors as well. So you can scale up and down and meet different cost and performance requirements based on the end market that you're trying to serve.
And security and safety is really, really key. And although there's security requirements in consumer, the level of security and types of attacks to protect against and the consequences of those attacks are pretty significant. So, I'm going to bring this back to Ian, because the second question I always think of that a boss is going to ask is like, what is the business case? How much is this going to cost us, and how are we going to differentiate ourselves in the market?
Sure. I mean, you do want to pick the right part for the job, and the other part of being able to be flexible in that case. So in some of our reference designs, we have microcontrollers that do hard real-time activities, and we tend to run Zephyr on top of that, and they're doing sensor processing and things like that. But picking the right part and the right cost-effective part for the particular project is important. So in this case of a robotic reference design, we have an automotive grade lockstep processor here, and we add to what you said earlier, secure element. So in addition to the security on chip, there's external secure elements, so the board can authenticate itself. And in all of our reference designs for robotics, we include a secure element that you can use as needed. So here you want a lockstep automotive grade processor, but when you're more cost conscious and building, say, a drone or something like that, you can use an i.MX RT that has extreme performance, but at a very aggressive price. Other types of things you might do is, say, on a battery management reference design, again, you want a lower cost automotive processor, but still your software enablement is consistent, and it lets you interface really easily because we're consistent in our software enablement to things like the ROS operating system.
Yeah, thank you, Ian. To build on that thought, I'm curious, Altaf, we've talked a lot about the different interfaces you need and capabilities and scalability of performance, security, safety. How do these platforms we're talking about help a customer of ours or a developer of mobile robotics bring something to market that's giving them a competitive edge?
Right. So I think that's one of the key things that Ian highlighted as well. We have all the different pieces that go into a mobile robot as well. Ian pointed to the real-time control unit, battery management unit, motor control. There's connectivity as well. So going to a vendor like NXP allows you to have a more integrated, cohesive software ecosystem that makes all these modules work together. So that helps you to go to market. But also when you have problems from a technical support perspective, one of the modules isn't quite talking correctly to another one, it's one vendor that you have to go to, to help debug that problem and help you to get to market more quickly.
Yeah, that was the third question I think of that a boss will ask is like, this is complex.
Right.
What is the investment cost? How many resources? What expertise do we need? So what you're saying is with these platforms and the modularity and flexibility and coming all from a single supplier where we are doing the work to do the integration so that customers or developers can focus their energy and resources on the upper part of their project and not on the foundational element.
Right, exactly. It's all the software drivers that work together with the robot operating system that Ian mentioned for all these different modules are available. So they should all work seamlessly. But if you do have issues, it's one vendor you go to debug that problem. If it's different vendors, then who takes the responsibility to help you resolve that problem?
I think another important thing to mention here is that, we also have a large ecosystem of partners. So people making SOMs, people providing additional software support or software subsystems that add on top of it. So it's quite a big ecosystem that NXP has in place to support these things.
So those are the 3 questions you need to be prepared to answer when you take a prototype to your boss. For more conversations at the edge, click on the link below.